Hello friends, welcome to this video on circles. Today we will discuss about the cyclic quadrilateral and a theorem related to it. Friends, we know that we can draw one circle passing through three non-collinear points. If we are given a fourth point here, three situations may arise. It is possible that the point is located on the circle itself. It could also be located in the interior of the circle. And it could also be on the exterior part of the circle. Here, we will focus on the first situation, where all the 4 points are located on the circle. These points are known as concyclic points. If the 4 vertices of a quadrilateral lie on a circle, it is called a cyclic quadrilateral. There is an interesting relationship between the angles of a cyclic quadrilateral, which we will try to find out with the help of an activity. For this purpose, paper, compass, pencil, scale, and scissors will be required. With the help of a compass, let's draw a circle of radius 6 cm whose center is O on the paper. Now take 4 points P, Q, R and S on it. Join these points to obtain a cyclic quadrilateral PQRS. Now, to understand the relationship between the angles, we will separate the quadrilateral PQRS from this circle with the help of scissors. And now, let's cut it into 4 quadrants like this. Friends, we have to determine relationship between angles, so we did not cut the quadrilateral PQRS diagonally. Now we keep these quadrants like this. You can see that in both these cases we are getting a straight line. That is, the sum of these angles will be 180 degrees. But we do not get a straight line here, so the sum of these angles will not be 180 degrees. And you can see that in quadrilateral PQRS, angle P and angle R are opposite angles, and also are the angles Q and S. So would it be correct to say that the sum of each pair of opposite angles of a cyclic quadrilateral is 180 degrees? Yes, friends, this statement will be correct. You can repeat this activity with more cyclic quadrilateral. Friends, this is a theorem that states that the sum of each pair of opposite angles of a cyclic quadrilateral is 180 degrees. We can also prove it mathematically. Let's prove it. According to the statement, here we draw a cyclic quadrilateral DEFG. We have to prove that the sum of each pair of angles opposite in it is 180 degrees. Here we draw a diagonal DF and diagonal EG. Then in quadrilateral we get these 4 triangles. Let us now see proof of this theorem. Friends, angle GDF and angle GEF are angles formed in the same segment, so they will be equal. Similarly, these two angles, angle FDE and angle EGF, will be equal. Let's consider these as equation 1 and 2. Now let's add these two equations like this. Friends, you can see that by joining angle GDF and angle FDE, we get angle D. That is, we can write angle D here. If we add the angle F to both sides of this equation, then the sum of the right side of this equation will be 180 degrees. Can you explain the reason for this? You can think by pausing the video. These 3 are the angles of triangle GFE. And we know that the sum of the three angles of a triangle is 180 degrees. That is, the sum of angle D and angle F will be 180 degrees. Friends, both these angles D and angle F are opposite angles in this cyclic quadrilateral. Thus, we have proved that this pair of opposite angles is supplementary. Friends, we know that the sum of the four angles of a quadrilateral is 360 degrees. We can write it in this way. Using equation 5, we can get that angle E plus angle G is equal to 180 degrees. Thus, we have proved this theorem that the sum of each pair of opposite angles in a cyclic quadrilateral is 180 degrees. Friends, will the converse of this theorem also be true? We will discuss this in detail in the next video. That is all for this session. Today we discussed about the cyclic quadrilateral and a theorem related to it. See you in the next video. Thank you.